So in this diagram, we will see the accept system call and select system call together in operation. So for example, let us say you have a TCP server, right? And it has maintained the read FDS, which is actually a set. So it is a set. And currently this read FDS has only one set, which is master socket file descriptor. So let us assume that your server has boots up. Let us assume that your server has booted up and it has created a master socket file descriptor already. Whatever file descriptor it creates, it has to add that master socket file descriptor to the read FDS set. So read FDS is actually a collection of master socket file descriptors. Sorry, it's a collection of file descriptors. So the first thing the server has to do is to add the master socket file descriptor to the read FDS set. And as I said, the first thing the server does is to create a master socket file descriptor and add it to the read FDS set. Now you can see here that the server has called the select system call. The select system call is called on the read FDS set. So whatever file descriptor are present in the read FDS set, the select system call is actually monitoring all those file descriptor. That is, the select system call is monitoring all those client connections with the server. And as I said, that select system call is a blocking system call. When this is executed, the select system call will block here. That is, the execution of the program flow will block here until the conditions of select system call, until the appropriate conditions which unblocks the select system call are met. So going forward, let us say we have a client C1 and it connects to the TCP server. So client C1, the first step, the client C1 sends a connection request to the TCP server, and at that point of time the TCP server is actually waiting on the select system call. And in the read FDS set, there is only one master socket, there is only one file descriptor which is being monitored, and that file descriptor is master socket file descriptor. So as soon as the client C1 sends the connection request to the TCP server, the select system call gets unblocked. Why it gets unblocked? Because the select system call was monitoring read FDS set, and read FDS set had only one file descriptor, which is master socket file descriptor, and master socket file descriptor is used to detect new connections from new clients. So in this scenario, the TCP server has detected that a new connection has received, that a new connection request has received from client C1. So select system call unblocks. So the second step that is taken by the server is to call the accept system call. Accept system call means the server has accepted the connection, and the return value of the accept system call is again an integer value, which is called communication file descriptor. So in this case, this is the communication file descriptor. It can have a value, any integer value like 6, 7, 8 or anything. It is this communication file descriptor that the server will use for data exchange with the client C1 for the rest of the lifetime of the connection between the client C1 and the server S. So you can see that the data exchange between the client and the server is happening using the communication file descriptor, which is the return value of the accept system call. Master socket was used only to detect new connection. Now once the communication file descriptor is created, the communication file descriptor is also added to the read FDS set. So in the read FDS set, now there are two file descriptors, the master socket file descriptor and the communication file descriptor. The purpose of the communication file descriptor is the data exchange between the server and the existing client, whereas the purpose of the master socket file descriptor is to detect new client connection requests from new clients. Now at this point of time, the server is again blocked on the select system call, and the read FDS set now has two file descriptors, that is master socket file descriptor and communication file descriptor of client C1. It means that, that at this point of time, the server is monitoring the new connections. That is, the server is monitoring the arrival of new connections from new clients, as well as the server is monitoring for the arrival of new data requests from the existing client C1. So at this point of time, server is doing both the things, because in the read FDS set there are two file descriptors. So the select system call is monitoring both the file descriptors. Now let us say from the new client C2 again a connection request arrived to the server. Select system call was blocked, right? As soon as the new connection request arrives, again the select system call gets unblocked, and because it gets unblocked, and the reason for unblocking is that the new connection request has arrived from the new client. Therefore, in this case, the accept system call will be called, and the return value of the accept system call will be another communication file descriptor. This communication file descriptor will be used for data exchange with the client C2, and this communication file descriptor will be added to the read FDS set. So read FDS set will now have three communication file descriptor. So at this point of time, the TCP server is now monitoring two clients at the same time, as well as it is also capable of accepting the new connections from new clients at the same time. So you can see that the select system call actually achieves multiplexing. Multiplexing means doing different tasks at the same time. At this point of time, because read FDS has three file descriptors, the server is actually monitoring three file descriptors at the same time. So more clients will come, more communication file descriptors will be created, and these communication file descriptors will keep on adding in the read FDS set. So we can say that the select system call is actually monitoring various client connections at the same time. So when we will have a code walkthrough, you will see the entire cycle that is discussed in this diagram in terms of programming. So what we discussed in the previous slide, I have captured that in the form of a flowchart here. So the first thing that the server does is to create a master socket file descriptor and put it in the read FDS set, right? And then select system call is called on the read FDS set, and the select system call is a blocking system call, so it is blocked. Right? Now, when the new client connection request arrives, only the master socket file descriptor is activated, because the purpose of the master socket file descriptor is to detect new client connection request. So when the new client connection request arrives to the server, the master socket will get activated. So let us assume that the new client connection request has arrived, so this condition will be true. When this condition will be true, the server calls the accept system call, that is, it establishes the connection with the client. And the return value of the accept system call is the communication file descriptor. Using this return value, the server will going to talk with the newly connected client for the rest of the lifetime of the connection. So this communication file descriptor is added to the read FDS set. At this point of time, the read FDS set will have a master socket file descriptor as well as the communication file descriptor. And again the server goes back and call the select system call, and it again gets blocked. That is, it again now waiting for the event from client, either from the connected client or from the new clients. If master socket file descriptor is not activated, it means that the server has received a data on one of the communication file descriptors. Now, server has to find out that which of the connected client has sent the data to me. And once it identifies that client, server serves that particular client, that is, the server replies back to that client. Remember the second argument in the accept system call? where we used to save the client information. That client information is used by the server again to reply back to the client. Now, server can choose, depending on certain conditions, whether to close the connection with the client and remove the client communication file descriptor from the read FDS. It will do so when the server no more wants to communicate with the client. So the connection termination can either be initiated from the server side, or the client can send a special message to the server. Having read that special message, the server can choose to remove the client from the read FDS set and close the connection forever with that client. So so that particular thing is done at this stage in the flowchart, and after servicing the client, the server again goes back and block on the select system call. So you can see that in this complete cycle, the server, whatever the servers do, it comes back to the block system call. Sorry, the server comes back to the select system call and gets blocked here. So actually you can see that the server is in the while one loop. So it is a property of the server that the server always has to be up and running, and therefore server runs in the while one loop. Right? So now we will discuss all these mechanisms, all these flowcharts, and all these server cycles with the help of an actual code walk. Then things will be more clear to you. So how to implement a TCP server? You have to follow these 10 steps to implement any TCP server. These are the generic steps, and these steps have to be followed in order to implement a TCP server. So let us have a code walkthrough and let us go through all these steps.